I'm really happy to see that many people, and especially happy that we are having this first open tour event in Vilnius and in Danske Bank. So thank you, Red Hat. Thank you, Danske Bank. So today we will talk about the evolution of container platform in Danske Bank. So my name is Liudas. I'm head of infrastructure engineering, and together with me is
First of all, I would like to say I'm really happy to be here. I'm saying for myself for the last 7 years when I'm going to the Danske office. So, yeah, my name is Aivaras Laimikis. I'm a team lead for container orchestration team. Yeah.
okay. So as any good container talk has to start with some container ship. So we have this out of our way and we can start. We talk not just about containers. So we'll start with the brief history of Linux in Danske Bank. And then we will talk about containers. Lastly, we'll touch briefly about the future. So let's start with some history. Right? Yes. So the Linux team started in 2015. So basically, we were tasked to take over support from our partners, just a few Linux servers. So this is how the team started. But we had some bigger ambitions. So, and the main one was to make Linux as a first-class citizen in our environment. So we knew that we need to do it right from the beginning. So what we did, we applied, of course, best security practices. We are a bank, of course. Then used infrastructure as a code from the beginning, from the start, and integrated Linux offering to all the internal systems. So, and it was getting popular, but it was getting popular among the infrastructure teams to run infrastructure services like monitoring, logging, and others. Also, Linux was used to run managed services like messaging or NoSQL databases. But it was not getting traction in the application teams. So what was the problem? So we were providing the Linux servers, and building and deploying application was like, you have to deal with this yourself as application team. So how you copy the files, how you deploy the runtime, how you deploy the your application code. Do you just copy files? Do you use package management? How you manage repositories, and so on. Also, Red Hat Enterprise Linux is not very famous for providing latest and greatest runtime versions. And it was not very popular among developers to use the old frameworks. They always want to use latest and greatest. So we had to do something. And to address those challenges, we started to think about providing some kind of application platform. And the project, unofficial project goal was production in a day. That means that you have code and you should be able to run it, all the infrastructure provisioned, application build, deploy, and run in a day. So that was the sort of unofficial goal. And in 2016, we started to look in the market, what product could meet our requirements. And Danske Bank is really heavy on .NET, so we have lots of .NET code. So this is naturally was one of the key requirement. But at the time to run .NET Core, not .NET Core, .NET framework, basically you have to run Windows. So your microservices become VM, which is not ideal. And .NET Core was really early product. It's just few new versions. So we didn't knew if it will succeed or not. And also that meant that application teams will have to rewrite or refactor the code to run on .NET Core. So, and in 2016, Kubernetes was new thing. It was not that popular like nowadays. We see everywhere. It's like no question how to run containers. But at that time, it was new thing. So, sorry about that. So, of course, as you know, we choose OpenShift. And today, it might look easy decision that, yeah, those technologies are very well established nowadays, but at that time we had to sort of take a bet that these technologies will be the core of our new container platforms. So, and rumor said that we were one of the first in Nordic financial companies to introduce containers in productions. So yeah, Danske Bank can be like modern and use new technologies. Thank you. And now Aivaras will talk a bit more about how we implemented the platform.
Great. So just one small note. Me and Liudas are very technical guys, but we're trying to avoid technical details too much. We will be available later and we can discuss more in depth about technical implementation architecture, which we decided to do. So yeah, so just to recap, our team was Linux team. We mainly focused on, at the time when we started, we mainly focused on Linux, configuration management, automatization. And the OpenShift, when we started as the big new journey, was really something new for our team. But we already had some knowledge how to run containers in our production. So in the end, containers are Linux. So that's the reason, I guess, why we were tasked to build OpenShift and support it. So first iteration with the OpenShift and Danske Bank, we built a stretch cluster deployed on 2 data centers. We have very small data center for the witness stuff, but basically a cluster was stretched on 2 data centers, and we allocated virtual machines for production and for non-production workloads. We heavily utilized namespaces, multi-tenancy on the OpenShift. So basically, as we call now tribes or application owners, teams were given isolated namespace with a lot of restrictions just to keep everyone safe in the OpenShift. So we heavily utilized multi-tenancy of the OpenShift. So this is the first iteration how it looked. I just few more things. We managed to provide dynamically provisioning storage. We used at that time innovative Ingress solution. We stay apart from HAProxy. At that time, it was maybe a mistake. Looking what we done, but it is how it is, and it was a very innovative stack at the time. So, sorry. So, using a stretch cluster between different availability zones kept our users from infrastructure problems and resiliency issues. So users didn't have to think about how the application will be resilient in case one of the data centers will fail. So OpenShift and Kubernetes could done automatic migration to one on another data center. So users were from the user's perspective, it was very easy to build applications and deploy. Another thing, when we had a central OpenShift offering, users didn't have to care about infrastructure, maintenance, patching. Everything was done by central support team. So it sounds good, but it not always work as expected. So keeping all the eggs in one basket, I'm talking about production and non-production, increase possibility of failure. So in case patching, configuration, and any changes fails on the OpenShift, it has the impact on all environments. So now I can say it was wrong decision to have single environment for single cluster for all environments. This unfortunately we had multiple those kind of disasters on OpenShift, but yeah, so I will talk a little bit later how we solved this. Stretch cluster problem was not the only problem we were not aware about. We don't have any knowledge how many users, deployers will use our environment. So after a few years of running OpenShift 3, we had thousands of projects. We have 10,000s of pods, applications running there. So we reached the limits of subnets. We reached the limits of the number of egress IPs. So we never thought that we will grow so much. So let's move on. So after a few years, OpenShift decided to release, Red Hat decided to release OpenShift 4. And OpenShift 3 was reaching end of life in a couple of years, so we thought, well, and there was no direct upgrade possibility, so we took an opportunity and decided to rethink what we have done wrong in the previous design, and with the OpenShift 4, rebuild in a much more nicer way. So the first thing what we decided to do is to split clusters. It's not just to split nodes, but build isolated clusters in a different availability zones or data centers. Create clusters for production, create for non-production. So we ended up in around 30 clusters. So for different environment, for different security zone, for different data center. And we decided to move away from the virtualization, move away from the fancy SDNs, because sometimes SDN on the SDN doesn't work as expected, and it's really hard to troubleshoot and find the root causes. Decided that Red Hat knows better how to handle ingress traffic and not to rely on proprietary tools which you can debug and where you don't know what's happening inside. So we decided to focus on HA proxy. So for us, it was really big improvement for infrastructure teams. But if we are talking about the tribes, application owners, there was a huge change in application design. One of the things, in the first iteration, you didn't care about the resiliency. Your application were migrated automatically. But right now, when we have two different clusters or more clusters, you had to take care of your application. First of all, you had to decide if your application is able to run active mode, active passive, or if your application your criticality is pretty low, so maybe you can just run on the one data center and don't care about anything. So those critical applications had to redesign applications and run multiple replicas in different data centers on different clusters. Another thing about state synchronization is it's a still huge question for some, because there is a lot of ways how it can be solved. Some of the teams doing application layer state synchronization, other teams are relying on, for example, database deployed outside of the OpenShift. And the third thing was load balancing between two data centers. It was something very new for the applications. But I'm happy to say that our network team solved the problem, so the application owners didn't have to reinvent something new. So do you think that this was approved and accepted by developers teams well? No, it wasn't, because it was a huge job to redesign the application. But on the other hand, I can say that for the infra teams, today we have 3 years and 23 days from the first cluster which we started, and we didn't have any major incidents on the OpenShift environment, which happens on the both data centers.
Okay, thanks, Aivaras. So we talked a little bit how we deployed the OpenShift and moved from like small scale to larger scale, and the failures and how we fixed it. Now, our container journey does not end with on-premises. We are looking at the public cloud, and we are in the beginning of the journey, but we already have a clear view where public cloud could help us to address some of the problems. So one thing as Aivaras mentioned, we rely heavily on bare metal servers, and extending and adding new clusters is really lengthy process. You have to add additional hardware. You have to actually forecast the resource usage and plan. And once you have server installed, you stuck with it for quite a while. So there is no easy way to reduce. So this is where public cloud will help a lot to use resources more efficiently and react to the demands much more quickly. And using the public cloud capabilities, we will automate the extensions of clusters or building the new ones. Also, by moving the OpenShift to public cloud, we are not introducing big change to application teams like we did with 3 to 4 migrations. So yeah, we learned that lesson. We will do the small steps. But what it gives us to application teams, that application will be closer to public cloud services, which are not available on premises. So, but however, there are some challenges or focus areas we have to work a bit more, and public clouds won't be able to like magically address those. So developer experience is one of the thing we will focus. Even if public cloud provides a lot of capabilities and tools to make developer experience much more smoother, but it still takes an effort to do that. So I believe that majority of use cases we can cover by just providing ready-to-use templates and abstracting in infrastructure. This is something we are lacking on the current platform, and it will be focus area for our next generation container platform. Thank you.